right, so today we're going to be looking at the evolution of human flight. So this serves as a good introduction to aerospace engineering. And, it's a topic that people, know a decent amount about, but they may not know some of the particulars. Okay, so we're going to talk and get into it a little bit. So why human flight? The desire to fly is an idea handed down to us by our ancestors who looked enviously on the birds and on the infinite highway of the air. And, they said, okay, how do these birds kind of get in the air? And, how does something like us that's heavier than air, how can we build a machine that maybe is modeled after birds? All right. So how did we progress? Applied science, technology, and math through engineering. So, they got this idea way back when that, balloons could be lighter than air, right? There are elements that are lighter than air. So things like hydrogen, helium, etc., are lighter than air. Okay, then we've progressed through, the Wright brothers, larger commercial and military aircraft, and then even into space. So it's really building off of one another and, building on the backs of what came before. Okay, so early aerospace engineering, you may have heard of Leonardo da Vinci. Factors such as technology prevented some of his ideas from becoming reality. However, since he wrote stuff down and took a really analytical view of things, once the technology caught up, a lot of the scientists and engineers kind of revisited that idea. Okay, so like I said, lighter than air, right? What inspired lighter than air flight? Somebody said maybe rising smoke, etc. But even until 1782, it couldn't piece together the right combination of materials, the right gases, and so on, to do this. So the Montgolfier brothers in 1782 kind of started that. Okay, of course, then here being from Ohio, we all know about Orville and Wilbur Wright. They flew the Wright Flyer on December 14th, and it only flew 120 feet in 12 seconds. So not very far, but they were able to create a much more controllable situation. Okay, they experimented with the idea of bending the wings, of kind of making a rudder, etc., and things like that, in order to really investigate this concept of lift. So they were able to use the design process in order for that to happen. Okay, so in 1 century, human flight progressed from flight of 6.8 miles an hour to thousands of miles, and then tens of thousands of miles if you talk about spacecraft. Again, a lot of pioneers, especially in the design, testing, and failing phase, really tried stuff. And it's amazing the aircraft that got generated before even the use of computers or calculators or those kinds of things. Okay, commercial aviation was catalyst for growth. Competition was a big part of this. So you had people like Charles Lindbergh, Amelia Earhart, etc., and then a need for people to get to places faster, right? They didn't want to take the train across the country. That would have taken like 5 days, or drive across the country. Oh my gosh. If you've ever driven somewhere, that takes a long time. So commercial aviation was a catalyst for growth. Okay? The military, a lot of people say that, wars and conflict spur great advances in technology. So in World War I, we went from biplanes. You guys may have seen like There used to be this company called the Red Baron Pizza Company. They made like frozen pizzas and stuff. Well, I don't know if they still do that, but the Red Baron was like this famous World War I fighter pilot, and so the Red Baron pizza, they put a little biplane on the pizza box. World War II, then, demand for aircraft was even more extreme. Just to give you an example, on the bomber front, okay, the United States started World War II with one version of a bomber called the B-17, and by the time the atomic bombs were dropped on Japan, they had gone through 6 more models already of just bomber aircraft to the B-29. So if you look back from the B-17 that started World War II to 4 years later, the B-29, that development is enormously different. Okay, then we moved into increasing performance. Captain Chuck Yeager flew faster than the speed of sound. Okay, that's what Mach is. We'll learn about that a bit later. Okay, continued development with commercial aircraft. Basically, the whole idea is to fly more passengers further with more fuel efficiency. All right, so you have hang gliders, you have private jets, and then you have like the Boeing 787, which is a actually considered kind of a medium-sized wide-body aircraft. Okay, rotorcraft, right? Helicopters. Again, from Leonardo da Vinci through this guy called Sikorsky, wide-scale production of helicopters to now, Coast Guard choppers, Black Hawks, Apache gunships, etc. Okay, they have drones that exist. Drones are becoming more and more widespread as we go along. We're going to skip kind of some of that drone stuff. Rocketry. The Chinese were credited with using rockets in 1232. All right. Russian space scientists developed equations in 1903 to reach space. So sometimes, the science is ahead of the technology or is ahead of the engineering. But then other times, the engineering gets ahead of the science and makes it possible. Like a lot of the stuff that we currently understand about our universe, galaxies, stars, etc., isn't possible until we got beyond the bounds of Earth, so to speak. Okay, American Robert Goddard, considered the father of modern rocket propulsion. First liquid-fueled rocket launch in 1926. You may have seen the movie October Sky with the little boy from, I think, West Virginia who did some stuff with rockets. Okay, space race, again, competition driving accomplishment. The United States versus the Soviet Union. Okay, President Kennedy made a famous speech about how the United States should commit to landing on the moon within the decade. Well, he got it done with about 4 months to spare. So success through determination. Engineering's foundation for continued exploration. We have SpaceX now that just launched Americans and returned them safely to Earth over the course of this summer on an American rocket for the first time in 10 years. All right, so again, space competition. So what's next? We're going to continue to apply science and math through engineering.